So now that we have that, let's go ahead and grab the data. Going to take the data over, and then we're just going to put it into the calculator. That's pretty much it. Of course, you guys know about all of this stuff. Probably can do it in your sleep by now. Convert and edit, and we know that this is going to go into, oh, still going into the ballistic pendulum. That's cool. So let's just look at our data here. And I'm going to just open each one of these. And I want to make it bigger, okay? So let's look at the data set here. We have 0, 0.090, 0.090, 0.0909 centimeters, 1 centimeter, no, that's a millimeter, 1 millimeter, 9 centimeters, 1 millimeter, 10 centimeters, 1 millimeter, 10 centimeters, 2 millimeters or 3 millimeters, 9 centimeters, 1 centimeter, no, 1 millimeter. So 1 millimeter is effectively 0 compared to 9 or 10 centimeters, okay? Because there are 10 millimeters to every centimeter. So it would be like 110 centimeters. So again, 390, and then we have 7. That's not even a millimeter there. That's 1 millimeter. It's like less than a millimeter. And we have our last point here. So all we need in the calculator is our y. Even though I looked at those, I can look at these and I can tell if these are correct, then my y's are correct. So you have 0 to 0.06 millimeters. So you have you have less than a half a millimeter here, and then you have like 6 millimeters, less than a half and 6. So this is one of the reasons why we do it like this, because the height is so small. Now we could use Pythagorean's theorem and telescope in by using the x direction and say, oh, well, we can see the x direction really well. And then we can calculate the height, the y, by using Pythagorean's theorem, if you know the length of the chord as it moves up. So that's a technique that we could use, but it's no need. We have video physics. So let's just grab this, say copy. I'm gonna go back, and that was the y direction. I'm gonna go into the conservation of momentum calculator. And we're just gonna go into our ballistic pendulum. I'm gonna go to C and then just paste. And you'll notice that I have not gone all the way down, but I could say that that's okay. I'm just gonna say fill and drag this down to include that. I'm gonna look at this average here, and I'm gonna replace my average, which is F:(F). That is inclusive of everything. If I touch on this, you'll see that goes all the way down. It's just gonna grab all of the numbers that are in there. The initial velocity is based on, what is this value? Why didn't it give me, G2. Oh, it's reading it as a text field. Let me make sure that it's a number. Go in, kind of change this a little bit, and it'll recognize it as a number. So now it's giving me 2.88 meters per second squared. We don't need all those decimals. 2 will do. And then we're going to replace this with our kinematic theory. So you go back to your initial velocity, find out what you had in initial velocity. It's way back here. 5. Open up your initial velocity calculator, and you'll see I have 3.1. So in this calculator, I'm just going to put 3.1. and it's going to give me some percent difference. Again, this is my precision, all right? If we're using this as a baseline, if we're using our kinematic theory as a baseline, this is our precision. All right, and that's the end of this. You just make sure that you go to Dropbox and you upload this folder. You'll notice that I'll have 4 files in here in just 1 second. Just go ahead and share this with me by sending the link, and then of course, copying the link. Cool beans? That will do it.